Number 4 in your math textbook. It's talking about scale drawings. Number 4 says, a scale drawing of a cafeteria is drawn on the centimeter grid paper as shown. The scale is 1 centimeter, semicolon 4. Okay. Letter A says, redraw the rectangle on a centimeter grid paper using a scale of 1 centimeter, semicolon 6. So here it tells you, and I need you to highlight this. Here it tells you the scale factor. Now, if you watch all the videos that I posted on the website, you can see that the scale factor can be written this way, but it could also be written as a fraction form, which looks like this. Now, obviously, if you get rid of the labels, you're left with just 1/6. And what that means is that you're going to take every dimension and you're going to either enlarge it by 1/6 or you're going to reduce it by 1/6. In this case, the image is shrinking, so therefore you're going to be dividing every dimension by 6. Okay, so first of all, you got to find out how much each dimension it measures. So in this case, all you got to do here is count the squares. So 1, 2, 3, 4, 5, 6. So this is 6. And let's find out the width. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one would be 9. So what this is saying, what the scale factor is saying, is that you're going to take every dimension and you're going to divide it by 1/6. Okay, so let me just complete my rectangle. And there it tells you what each section of my rectangle measures. So there's actually several ways I could do this. I can set up a proportion, or I could just simply divide each dimension. Okay, since it's a rectangle, I'm only gonna focus on the length and the width. Okay, so if I take the 6 and then divide it by 1/6, that's gonna give me the answer that goes on this side. Okay, so just like I've taught you, if you're dividing fractions, you need to either have both fractions or both whole numbers. So in this case, I'm gonna turn this into a fraction so that now I have 2 fractions. So then you do your copy, change, flip, and you're left with 6 times 6 over 1. Okay, so then I end up with 36 over 1. Now, there's a mistake that I made here, okay, that I wanted to make sure that I point out, because it shouldn't have been dividing by 1/6. It should have been multiplying by 1/6. And let me show you the difference in answer, okay? And it's good that these things come up so that I can explain it to you. So I'm going to take this same thing and then I'm going to multiply times 1/6. So then again, you're doing it for 2 fractions. So then I'm going to put this over 1 and I'm left with 6 over 6, and that obviously equals to 1. Now, if the image is shrinking, should have my answer been 36, or if the image is shrinking, does my answer make more sense for it to be 1? Okay, in this case, obviously the number is going to be lower because the image is shrinking, so my answer should have been 1. So my new rectangle, my new length would be 1. And if you notice, if I'm going to draw a smaller image of this particular figure, the measurements over here need to be smaller than the ones over here, right? Okay, so I'm going to take my same idea and I'm going to figure it out for the width. So I'm going to take my 9 and I'm going to multiply it times 1/6, because that is my scale factor. Remember, every dimension is shrinking by 1/6, or is being reduced 1/6. Okay, In this case, again, I have a whole number in a fraction, so I'm going to put this over 1, and I'm left with 9 over 6. If I reduce it, how many times is 9 going to 6? Go ahead and do that on the side. 9 over 7. How many times is 9? Ones. Add the 0. 1.5. Okay, so then that tells me that my distance here needs to be 1.5. Now obviously because it's a lot smaller, all I gotta do is cut one of these little rectangles in half. My width is now 1, my length is now 1, my width is 1.5. But if you notice, every single dimension got reduced once by a scale factor of 1/6. Does that make sense? And obviously, since it's a rectangle, all I gotta do is draw the bottom, and obviously the top is the same distance. Okay, so redraw the rectangle on a centimeter grid paper using a scale of 1/6. Okay, which you took every measurement and you reduced it by 1/6. Okay, so that's the answer A. Here's my new picture. Here I kind of messed up, but I mean, if you redraw it kind of using a ruler, it would look something like this, but a lot smaller. Let's go ahead and talk about letter B. What is the actual length and width of the cafeteria using the original scale? What are the actual dimensions of the cafeteria of a new scale? Okay, and although I don't want you to answer this one, I do want you to pay close attention to the scale factor that they're using over here. 1 cm or 1 centimeter, semicolon 4, can also be written as what? 1 cm or 4 meters, which also can be written as 1/4. And what this is saying is that this little picture, this is 1/4 of the actual cafeteria size. Okay? And that's kind of how they use the scale factor. So they use the scale factor to reduce it to this, and then they use a new scale factor to reduce it to this. So if I kind of work backwards, I would be able to find the original length. And obviously that's what they do in plans when they have architecture plans. Okay, but this you do not have to answer. Okay, so do not answer. Okay, if you have any questions, just go ahead and let me know. I hope this explanation helps, and you can answer the rest of the questions on your homework and your classroom. Okay, thank you.